Okay, so I'm a bit ill, but we're going to try and go through this toy plane question. So you've got the mass of a plane is 0.02 kg, the extension of the spring is 0.12 meters, spring constant is 50 newton meters, and the maximum speed of the plane when the spring is released is what you needed to calculate. So this question is all about conservation of energy. Okay, so we need to know that all the elastic potential energy is converted into kinetic energy because energy cannot be created or destroyed. So all that elastic potential stored in this spring over here must be converted into pushing that plane out. As obviously the plane is being pushed out by the spring, that plane will start moving, and that moving energy is known as the kinetic energy. So we can first calculate the elastic potential energy. So that is EP, which is equal to a half KE squared. Now that is EP is equal to a half times the spring constant, which is 50 Newton meters, times that by the extension, which is 0.12. So times that by 0.12 squared. That gets the elastic potential energy of, I think it's 0.36. Yeah, 0.36 joules. Now, we can equate that elastic potential energy to kinetic energy because all that elastic potential energy stored inside that spring must be transferred into pushing and moving that toy plane out of the spring and into the air through kinetic energy. So 0.36, the elastic potential energy, is equal to the kinetic energy of the plane because energy is conserved. So we know that the mass of the plane is 0.02, so we can say that 0.36 is equal to a half times 0.02 times velocity squared. Rearranging this formula, you can get 0.36 over a half times 0.02, which is equal to v squared. But obviously, we don't want v squared, we want v, so we've got to take the square root. So 0.36 over a half times 0.02, taking the square root of that will get you bang on 6 meters per second, which is the answer to the question.